Hello, today we're going over section 4.3, adding and subtracting rational expressions. In this video, we're going to go over problem number 8, number 9, and number 10. Recall that in order to add or subtract a rational expression, you start by finding a common denominator. Then you fix the numerator, then you combine like terms, and you're there. Let's look at our common denominator. So x squared plus 2x will factor into x times x plus 2. Notice we have an x in the first denominator. So what can both denominators multiply into? And the answer is x times x plus 2. So we have x times x plus 2. In the first fraction, we say, how do I get there? What am I missing? I'm missing an x plus 2, so it's 4 times x plus 2. And then in the second expression, we already have all of the common denominators, so we just subtract 2. Then we distribute the 4, so this becomes 4x plus 8 minus 2, and then over x times x plus 2, and then combine the like terms of 8 and 2. So in the end, I get 4x plus 6 over x times x plus 2. Now, we could factor out a 2 and get 2x plus 3, but there's no other pieces in the denominator that could divide with that, so we don't need to worry about doing that. If you could factor something out and get an x plus 2, you want to do that so that you can simplify the x plus 2's. So should I just simplify the x's? I mean, let's divide those. No! You can only divide if you're multiplying. Notice I'm adding the 6. If I'm multiplying with possessive parentheses, it's okay if there's adding or subtraction inside. But I'm not. I have 4x plus 6. If you're adding, you cannot divide the x's. If this was in parentheses, maybe x plus 2 and an x, then I could divide it. But since you're adding, you can't. All right, let's look at number 9. I need to find a common denominator. So I factor a squared minus b squared, difference of squares. So that's a plus b times a minus b. What is the common denominator? What can both multiply into? And the answer is a plus b, a minus b. You're taking as many of each distinct prime as you can. These two have a minus b, and this one also has an a plus b. That's how you find that least common denominator. All right, what am I missing in the first fraction? Nothing, so I leave 5ab. What am I missing in the second? I'm missing an a plus b. So I have the a plus b that's in the numerator and also the a plus b that I'm missing to get to that common denominator. Remember we talked about this as fixing the numerators. So I have an a minus b. How do I make the common denominator? I need to multiply by a plus b. I can't just do that. I've got to multiply by 1. So I multiply by a plus b over a plus b, and that's how you have that in the numerator. Okay, let's distribute and combine like terms. So distributing the a plus b times a plus b. So we get 5ab, and then we get plus a squared plus ab plus ab, so plus 2ab, and then plus b squared. Once again, this is all over a plus b, a minus b, and then combine the like terms. So in the end, the answer to problem number 9 is a squared plus 7ab, because we added that 5 plus 2ab, and then plus b squared, all over a plus b, a minus b. And now we'll finish with problem number 10. We need to factor, so two numbers that multiply to give you 9 and add to give you 6, so 3 times 3. So x plus 3, x plus 3, 3 times 3 multiplies to give you 9, 3 plus 3 adds to give you 6. And then x squared minus 9 is the difference of squares, so x plus 3, x minus 3. Now we need the most of each distinct prime, so we need x plus 3, and x minus 3. Okay, so that's our common denominator. X plus 3, there's 2 of them, so squared times x minus 3. The most of each distinct prime, or what can they all multiply into? X plus 3 squared can't multiply into x plus 3. It's already too big. So remember, you're looking for the highest exponent when you're thinking about variables or binomial terms. Now we fix the numerator. So what am I missing in this first numerator? An x minus 3. So I have negative x minus 3, and I'm missing an x minus 3. And then I'm subtracting. Sometimes I like to draw that bigger if I'm subtracting this whole numerator so I don't forget to distribute. And what am I missing here? I'm just missing another x plus 3. So put in parentheses the negative 2x plus 5. And then I'm missing the x plus 3. Awesome. Now I need to distribute, including the negative, and combine like terms. I could also factor out a negative and make this x plus 3 if I wanted to, or I could distribute the negative, whatever you think is easier. I think it'd be nice to just take out a negative there, so I'll take out a negative, I'll have x plus 3, and then x minus 3, and then here I'll distribute, so a big minus, and then I'm subtracting this whole piece, which will be negative 2x squared minus 6x plus 5x plus 15. Let's combine some like terms and keep going here. Remember, all of this is in the numerator, and so we're still over this denominator. So x plus 3, x minus 3 is the difference of squares, so it'll be negative x squared minus 9. And then I can distribute the negative, so negative x squared plus 9. Then when I combine like terms here, I get a negative x. So let's take the negative through, distribute that negative. So this would be plus 2x squared plus x and then minus 15. So you're combining like terms to get negative 2x squared minus x plus 15. And then you distribute this negative to get plus 2x squared plus x minus 15. Now let's combine like terms here. So I see a 2x squared minus x squared, which would give me x squared. So x squared plus x, and then I can combine the 9 and the minus 15 to be minus 6. Now, can I factor? 6 would be 2 times 3. So this is my new numerator, and now I can factor to x plus 3 times x minus 2. Negative 2 times 3 is a negative 6, and 3 minus 2 is 1. It's nice to leave that denominator. So we worked on the numerator. This whole piece was just the numerator. Don't forget, it's over that common denominator of x plus 3 squared times x minus 3. This is the case I had mentioned earlier. It's good to factor so that you can see if any pieces will divide out. Now, notice everything's in possessive parentheses, so I am multiplying, which means I can divide. There are 2x plus 3 terms here, so one of them will divide to 1, and I'm left with x minus 2 in the numerator and x plus 3 times x minus 3 in the denominator. Have a wonderful day.